Hey guys, we're going to do a quick summary, kind of like a review of momentum and impulse. This is great for the quiz tomorrow to get you guys ready. Maybe hit upon some weak points that you need to do some studying on. Refer back to the notes, pause the video, and replay as many times as you need. And let's get started. Alright, so we know the formula for momentum. An object that's in motion is said to have momentum. We gave that the symbol P, and it's equal to the mass multiplied by the velocity. Velocity is a vector as well. Then we kind of talked about something when we changed the momentum. We said, alright, a change in momentum is equal to a mass multiplied by the change in velocity. The mass isn't changing, it's only the velocity. So this here was our change in momentum. This is equal to m times delta v. Next we talked about, okay, well, in order to change delta v, in order to change an object's motion, we need to apply a force. Net force. And we said it's not only the net force that matters, it also is the time that we apply that force. We gave this a name, we called it the impulse, right? Then we set you guys free and we said, alright, do a lab, come back and tell us what you find. And you found that delta P, our change in momentum, was equal to our impulse. Alright, cool. So we know that, but let's explore further. We know another type of formula for change in P. We said it's n delta V on the last slide. And we also know another formula for impulse. This J guy over here, we know it's F net multiplied by the time. And this makes sense because delta P is equal to J. Just plug in what we know delta P is equal to and what J is equal to, and this is the formula we get. Now this formula, just in case you don't memorize it between how many practice problems we have done, it's okay. You can find it in the reference table in the back. The only thing that you do need to remember is that when we're talking about change in P, this change in momentum, we're talking about m delta V. Alright, that's not specifically stated on the reference table. You'll find big J is equal to F net multiplied by T is equal to change in momentum, this delta P. You gotta just know that when we're talking about change in P, it's n delta V. When the velocity is changing, that's when the momentum changes. Alright, cool. So now we have our formula. The only thing I really want to stress to you guys before you take this quiz, because I graded the labs and this is one of the major struggle points with you guys, is delta V. When we take a change in something, it's not just any quantity minus any other quantity you find in the problem. It's going to be final velocity minus initial velocity. Doing this in the right order will give you the right sign and it'll give you the right value. More importantly, it'll give you the right direction. You need to remember VF minus VI. The second you just say, oh, change of velocity, VI minus VF, and it'll give you a different value and you'll get the question wrong. Alright, so you need to commit this to memory. Delta V is equal to VF minus VI.
They know that. Hey guys, Miss Dovey here. Now we're going to do a few practice problems with momentum and impulse so that we can be really ready for that quiz tomorrow. So here's the first problem. A 40 kilogram mass is moving across a horizontal surface at 5 meters per second. What is the magnitude of the net force required to bring the mass to a stop in 8 seconds? Take a minute and pause the video and do it out on a piece of paper and then follow along with as I do it so we can see if you get the right answer. Okay, you better have paused that video, and here we go and get started on it. Okay, so let's go back and write down what we know. First, in the first sentence, we can find that we have a 40 kilogram mass, so we can write that down. 40 kilograms is moving across a horizontal surface at 5 meters per second, so that's a velocity. We'll write 5 meters per second. What is the magnitude of the net force? So that's what we're trying to find, F net, required to bring the mass to a stop in 8 seconds. So that's our time. So from that, we can go back and write down what we know. We know that we need to use an impulse equation because it says that we are bringing a mass to a stop. So knowing that, we know that in order that the mass initially had momentum, and now that it's stopping, it is a change in momentum, which is an impulse. From that, we can write down our equation. We know that the change in momentum, like Mr. Jones said, is m times change in v, and impulse is F net times time. Now let's go ahead and plug in what we know. We know the mass is 40 kilograms. Now we need this change in V, and like Mr. Jones said, it's VF minus VI. We know our VF, our V final, to be stopping, so we can say that that is 0. And our initial velocity was what we wrote down earlier. It's the 5 meters per second. So we can write down that our change in velocity is -5. So up here we can plug in -5. Our force is what we're trying to find, and our time is 8 seconds. So now if we go back over here and go ahead and solve that out, we can say it's -200 is equal to our F times time. Divide that through, and we find that our force is equal to -25 newtons. Now, up here it says that we need to find the magnitude. It doesn't say direction. Therefore, the negative really doesn't mean anything, and we can say that our answer is 25 newtons because that's the magnitude. The negative is only there if we need to solve for the direction as well. Alright, well, I hope you guys all got the same answer as me. If you did, congratulations, but let's move on to something a little more difficult. The other day we talked about force-time graphs. So we had force and we had time. If we were to graph the force-time graph of a baseball hitting a bat, it would be something like this. So you can say, like, this is 1 second, this is 3 seconds. The force up here is something in newtons. We'll say like 10 newtons. But from this graph, we can find something really important. If we can solve for this area right here, the area, we can solve for our impulse. And I know a few of the other day remembered this equation, but it's important that you do put this to memory. But area of a triangle is 1/2 base times height. So our base down here and our height right there, we can plug in for both those variables and solve for J. Once we know that, if we are given the mass, if we're given a mass, say the mass was 1 kilogram, we can go back down here and know that J is equal to our mass times change in velocity. If we plugged in for mass, then we can solve for our change in velocity, which could be very important for your quiz tomorrow. So I would try and bring out the problem that you did in class so that you can really understand how you can solve for your change in velocity. Okay guys, so for tomorrow I want you to do this practice problem I'm going to give you, and if you fill it out correctly, you do it on a separate sheet of paper. Show all your work, not just circle the multiple choice. Do all your work. If you get it correct, we will give you 1 extra credit point on your quiz tomorrow. So here is the problem. I want you to do it all out, and if you can do it, we will give you that extra credit point. Thanks for watching, and good luck tomorrow.